Let's practice. We have another example and let's check what we have over here. This is my voltage source. This is my I total. This is going to be also my I total, and this is my I1. This is my I2. What we're supposed to find? We have to find voltage source. We have to find I total. We have to find I1. Okay, so from where I supposed to start solving this problem? I'm going to start always from the component which has two pieces of information. Look at resistor R2. R2 has the resistance and also has the current. If I have resistance and I have current, I can find voltage across this resistor. And keep in mind that in parallel circuit the voltages are always the same. Okay? Now, so voltage source is equal to VR1. This is also equal to VR2. But some of you can have difficulties to find out if this circuit is series or this is parallel, this is series parallel. So in order to simplify this a little bit for you, I'm going to redraw it. How am I supposed to do that? Let me just call this point A. This is ground, but this is my point B. Okay, I'm going to draw my modified diagram over here. So this is my point A and this is my point B. Point A is connected to resistor R1, okay, and other terminal of resistor R1 is connected to the ground. Other words, is connected to point B. So I have my R1 over here, okay, connected to the points A and connected to points B, and I have resistor R2. Okay, so as you can see, these two resistors are in parallel. This is my R1, this is my R2, and in parallel circuit the voltages are the same. So next I'm going to find the voltage VR2 because I have given two pieces of information. So VR2 is equal I2 times R2 because voltage is equal current times resistance. So I have 1 milliamp times 36 kilo ohms. 1 milliamp times 36 kilo ohms is equal 36 volts. But let's check how we're supposed to plug in these numbers into the calculator. So I have 1 exponent 3 negative times 36 exponent 3, okay, because this is kilo, equals 36 volts. So at the same moment I know my voltage source, which is also equal to 36 volts, and VR1, which is also equal to 36 volts. Next we're supposed to find I1. Okay, I1 is, this is my I1. I1 is equal to VR1 over R1 because I found the voltage already, which is simply 36 volts. And if I'm going to divide this by the resistance of resistor R1, I'm going to find the current which goes through this resistor. So this is what, 3 kilo ohms, okay? So 36 volts divided by 3 kilo ohms is equal 12 milliamps. But let's check how I'm supposed to enter this into the calculator. So I have 36 divided by 3 exponent 3 is equal 12 milliamps. So I found I1. If you want to find I total, you're supposed to use KCL. KCL says that total current is equal to the sum of the currents, okay, in the circuit. So it means in this case this is going to be equal to sum of the currents I1 and I2. I1 is equal to 12 milliamps plus I2, which is equal to 1 milliamp. So I total is equal 13 milliamps. Okay, so I found voltage source, I found I total, and I found I1. But let's check if our answers are correct. So what I'm going to do right now, I'm going to find the total resistance. R total is equal voltage source over I total. Voltage source we found is equal 36 volts and I total is equal 13 milliamps. Okay, so I have 36 divided by 13 exponent 3 negative equals 2.76 kilo ohms. 2.76 kilo ohms. Okay, this is my R total. Now I'm going to use a little bit different method to find R total. Now I'm going to use just resistors. So we have two resistors, that's why I'm going to use the product over the sum. So I have R1 times R2 over R1 plus R2. This is equal. R1 is equal 3 kilo ohms and R2 is equal 36 kilo ohms. Okay, so we have R1 is equal 3 kilo ohms times R2 36 kilo ohms divided by open parenthesis 3 kilo ohms plus 36 kilo ohms. This is equal 3 exponent 3 times 36 exponent 3 equals divided by open parenthesis 3 exponent 3 plus 36 exponent 3 close parenthesis equals 2.76 kilo ohms. 2.76 kilo ohms. As you can see, these values are identical. We found R total using two different ways and we got exactly the same answers. So it means that our problem is solved and all our answers are correct.